Hello, and welcome to today's FIATech webinar, Material Readiness, the bridge between materials management and construction. This session will provide you with insight on the difference in material readiness and material management. My name is Eva Keitel, and I will be your host today. As we prepare to welcome our presenter, please take a second to find the question box in your webinar panel. And as you think of a question, type it in. We will make time at the end of the presentation to answer questions. At this time, I would like to welcome Robert Ball. He is the CEO of Atlas RFID with over 16 years of experience in project management and leadership responsibilities. Please welcome Mr. Ball.
Thank you, Eva. It's a pleasure to be here today with you folks, and thanks for joining us in today's webinar. I'm Robert Ball, the COO for Atlas RFID Solutions. Today I'm going to share with you my experience with implementing RFID-based technology on industrial construction projects and how that's being used to enable work processes to increase supply chain visibility and bridge the gap between material management and construction. So here's the agenda, and I'll begin by explaining our definition of materials readiness, what that is, how that's different from materials management. I'll go into some detail on how that's being implemented on capital projects and what are the components and the steps that you can take to implement that type of solution. And then I'll go into some of the business analytics that can be achieved and realized when that system is implemented. So I guess first I would like to just share a little bit about my background. And prior to coming to Atlas, I spent a number of years as an EPC project manager. And what I took away from that is there's just a lot of frustrating time spent reacting to issues that pop up with little or no warning. I mean, a lot of that role is very reactive. It's a very firefighting type role. And what kept me up at night on projects was wondering what issues are brewing that I wasn't aware of yet. What's gonna pop up and bite me that I need to react to? What are the things that I'm not yet aware of, but I should be, so that I can address them now before that fire starts, right? I want to be doing fire prevention. So, and ultimately, what can you do today to stop that fire from happening 3 days from now, 3 weeks from now, 3 months from now? And how do you get that data? And it just still baffles me on how tough it is to get good data, good reliable data, real-time data, a single source of truth, and visibility to be able to make decisions specifically to support construction. Across the supply chain with the growing global complexities of capital projects, it is extremely difficult, and I wanted to be a part of solving that problem, and that's one of the reasons I came to Atlas. And I'm sure everyone on the call can relate to a similar story and has scars on their backs related to material challenges on previous projects. And so that's our goal. I mean, it's to try to leverage technology to give project teams real-time information through increased material visibility to make better decisions. And I'm excited for the opportunity to share some of my experiences with this group. And thank you for FIATech for putting that together. FIATech is created to advance the integrated systems and technology-enabled work processes so we can deliver capital projects more efficiently. And I love that. That's my passion, and I'm excited to share my experience with you today. So, as I said, we're with Atlas RFID Solutions, a privately held company in Birmingham, Alabama, offices in Houston, Calgary, and Seoul. We've implemented RFID-based technology exclusively for industrial construction market in oil and gas, power, chemical, mining, projects across the world, over 300 site implementations on 10 different countries. So as I talk today, it's through that experience from our team and implementing these types of systems to help digitize the supply chain to improve capital performance is where our experience comes from. So our purpose in life, it exists to transform the industrial construction industry, leveraging mobile and AutoID technology across the supply chain to increase material visibility and location status to make informed decisions so that we can ensure construction does not wait on materials. And that's what we call material readiness. So let me differentiate that between material management, and I'll start talking about CII and the research that they have done within materials management. There's a lot of great resources. Now that FIATech is formally integrated with CII, those resources are available, and there's a ton of stuff. So I'll talk about a few of those. CII initially published a project materials management handbook in 1989. And as concepts and techniques for material management evolve with the changing the global environment and everything, they've updated it, well, once in 99 and once in 2010. So it's a resource that keeps getting updated with the times through research and through project teams. And here's the current definition. The updated definition is part of Research Study 257. This was conducted in 2010. There's a lot of words here. It's actually shown pretty well in a visual diagram here. So material requirements and planning, and what are the specs required for the job, taking that from engineering, pulling that in to start the procurement process on what do we need to buy. How are we going to source those materials? There's an optimization between not just cost, but quality and schedule to get those materials sourced and delivered to the project efficiently. The purchasing side on what the material and the equipment that we need to buy. Subcontracting falls within the materials management procurement scope for the services that we need to procure for the project. The expediting and delivery within accordance with the contract and the requirements. The quality management, the transportation and logistics to get that material delivered timely and efficiently. The site materials management from your warehousing, storing, requesting, issuing that materials, to include the material management for operations and maintenance that goes into spares and preventive maintenance and services according to OEM guidelines. And I mean, I think one of the gaps that we've seen in this, just inherently, not for any lack of focus or anything, just inherent gaps that exist, is there are teams within the organization structure that are dedicated to answering these questions and contributing to the overall project that become siloed. They're their own swim lane with their own team. A lot of them have their own systems. It's hard to get that communication between stakeholders and functional groups. It's hard internally, not to mention hundreds of suppliers and getting to a single source of truth to support the project. So FIATech has shown this as in another presentation as a world of worlds. So it is a very siloed tendency that happens, where I think the worst part of this is that it can create an individual functional optimization where each of those swim lanes are incentivized to optimize their function and not a whole system optimization. So ideally, decisions are made that support the best project outcomes overall, and current silos and data across those participants in the supply chain can start to impede visibility, and then we start getting reactive. And there's an opportunity to integrate the data across that supply chain and make material status and availability more visible and improve the planning and mitigate risk. And so I want to kind of set the stage there for kind of a common goalpost of what falls within materials management. It's very complex. It includes a lot of functions. And through our experience on these projects interfacing with owners and EPCs, I think everybody does this very well. There's a very robust processes, that companies have developed, a lot of systems, but there are inherent gaps. I think that's the opportunity is how can we leverage technology and process and people to close some of those gaps so that we can make some substantive improvements to project performance. And for us, what we've seen the biggest area for that gap is within materials management. Obviously, that is a very procurement centric view of the world, right? All of these swim lanes here are focused on, materials that we need to prepare, plan for, buy according to spec, and get to the site. The gap that I believe is the lowest hanging fruit in being able to support the overall project performance is related to construction. I believe there should be a construction-centric role within materials management that is focused on will construction wait on materials across that life cycle. And that's what we define as material readiness. And I don't want to insinuate that folks aren't doing this today. There are clearly folks that are looking at supporting construction. There are readiness reviews that happen as part of advanced work packaging. There are constraint management, those types of things. And let me kind of relate that to AWP. So, prior to AWP being published as a best practice within CII a few years ago, we still did planning for projects, right? It's not that we didn't do them. It's that we've found a way at leveraging technology and modifying process to focus more on construction and the path of construction earlier in the process and make that formal and create a dedicated role for that for the AWP manager, for the planners that get involved earlier. And those activities were still happening, but the point being that the increase in performance that's realized through providing a very focused functional group for the specific purpose of planning for the path of construction to support that project gets results. So our view here is there is a role within materials management that is a gap that can be solved formally through a structured functional lane that involves people, process, and technology. On the people side, there should be a coordinator that is empowered to make decisions across the total project performance, not just a buying optimization or a transportation or logistics optimization, but for the purpose of construction readiness, if they have the visibility for where issues are going to impact construction, that they can then make those decisions. So material readiness answers that question. Is construction going to be waiting on materials? Is construction going to be impacted? And to do that, we've got to combine three different things that I don't think that are really enabled by technology. So the first one is getting to a single source of truth for material status and location. Yeah, this is the hardest thing, where you have hundreds of suppliers, sub-suppliers. They've got their own reports. Project teams are being fed fabrication reports, PDF or Excel. They're getting inventory reports from different locations and different systems, some in Excel, some in robust systems. You've got P6, you've got a material management software, you've got a lot of different access to information. They're just not in real time, and they're not in a single viewable system that you can tie relationships to them to make decisions. So we've got to solve that problem. We've got to get to a single source of truth, so that we're all looking at the same thing. The next thing is, it's got to be integrated with construction need dates at the bill of material level. So even for companies who are doing AWP, and you have a system to do that, you've got required at site dates, you've got your RAS dates at a work package level, that includes the BOM, that's in one system. Oftentimes what we've seen is that's not integrated with the real-time source of truth of where that material is. So if we can leverage the technology to provide that source of truth and then integrate the bill of material level, whether that's through a work packaging tool or through P6 or imported through a drawing, you got to make that connection between the bill of material, construction need dates, and the record of source for that, and tie that to the material, the single source of truth for material. So let me explain a little bit better here what that means. So read this with me here. Material readiness, the functional component within materials management. So it is a materials management function. It's a construction-centric view, but within materials management, a role that ensures construction crews have the required material to complete their work according to the plan. So we've got to get them access to the RAS dates for construction. We've got to empower them and give them the tools necessary to provide that visibility, and then give them some reports and analytics to be able to make decisions on that. So I have these 4 bullets here. I want to talk about each one of those real quickly. So it provides real-time visibility. So this is not looking at a static report from your fabricator that's 2 weeks old. This is providing a system for your project that leverages either a barcode scan or an RFID read, some type of auto identification through the supply chain, that you get status updates where you can always know where that material is. This is very similar to you order something on Amazon Prime or through FedEx. I can go on my app, I can view in real time. I know the last time that my package was read. I know exactly where it's at. We're starting to get there on job sites and the individual project that we can get that visibility. A lot of companies are investing in that. But I'm talking about through the whole supply chain. I'm talking about prefabrication all the way to installation. We have got to get there where we can have a single source of truth in real time, where we know at different scans across that life cycle exactly where that material is. The next is geocontextual. So what I mean by that is, relative to where that material is, we should know some certain things about it, or some certain requirements to support the process. The way to think about this is like configurable workflows. So if I have a pipe spool that gets arrived on the site and I scan that, I know that it's a pipe spool. I know that I'm at a marshaling yard. And because of that, the system already knows what work steps I need to go through to support visibility downstream. So maybe that's capturing a receipt inspection, an OS&D, maybe it's validation of vendor documents, whatever that is, that geocontextual configuration to be able to guide the end user on which activities they need to be able to do. And then relational visibility. So this is in relation to not where it is today, right? That's the real time, exactly where it is, but relative to where it should be in the process. So if I have a pipe spool at the fabricator shop going through QC, then that's great. I've got real-time visibility into that, but where should it be in the process? If I need that at the job site tomorrow, then that's not good. If I need it there a year from now, maybe that's not good early either. Maybe it's too early. So that's the relative to where it should be in the process. So we can start to get away from just in case planning, and we can get more towards just in time planning. And that's a conversation that happens all the time with, construction generally wants their materials ahead of time. Just give me my materials so I have flexibility to be able to do my work. There's a huge cost to that. And in other industries like manufacturing, inventory is the definition of inventory is waste, right? I mean, it's not a good thing. You're paying for something that is not being productive. So if we can get that relational visibility, we can start making decisions to reduce that waste and reduce costs. Okay, so let me tie it back to the overall problem. Like, what does this impact, and what are some of the benefits? So, we've all seen the glooming numbers on project performance and overruns and that kind of thing. I'd like to highlight a study McKinsey recently put out. This was in June of last year, on how construction can improve from a digitization standpoint. Construction is the second lowest rated industry among the least digitized. That's terrible, but at the same time, that creates a huge opportunity. So they go into some examples on how the industry can embrace the technology, the digitization, and be able to reverse that trend. And they go into 5 areas of where we can make the biggest difference. So I'll talk about the Internet of Things and the digital collaboration. So on the Internet of Things, this is, enabling intelligent asset management and decision making. So the number of people, equipment, material, the work performed at the same time on a construction project is getting denser. And most of that data is not being captured today, let alone measured or processed. So we have a huge opportunity to capture all of that data and then transform that into information that informs decisions. So this study, imagine the digital future where the Internet of Things would allow construction machinery, equipment, materials, structures, all connected through sensors to a common platform where productivity and reliability of both the staff and the assets can make automated smart decisions that were never before possible. So CII and COA have done a labor study on productivity of craft, and we've seen this. There's 35 to 45% of a craft's daily time is spent on tools. So the biggest reason for unproductive time is they are waiting on materials. 15% of a craft's time is spent waiting on materials. If we look at a $1 billion construction job, that 15% applied to the direct labor is a $60 million problem. Through, what we've done with material readiness and the implementations we've seen a reduction in that time between 3 to 5%, which represents a 12 to 20 million cost reduction. And that's the low-hanging fruit. I mean, that's just leveraging some auto identification technology, trying to get to that single source of truth, and being able to empower decision makers who can influence the total project performance and get craft more productive. So looking kind of why this exists, and again, we go out and we do our project assessments. We'll go out to the job site. We'll walk the field processes with the team. We'll understand how they're doing it today, and this is what we typically see. Let's talk about a shipment. A shipment of pipe spools comes in, gets to the receiving area. We've got a paper-based packing list. We're going to take that packing list. A warehouse personnel is going to start doing their kick and count. They're going to check off the spool number. That's generally, it could be on a barcode, or it could be on a label, or it could be written on a paint stick, paint marker. We're going to mark all that up, and we're going to note any damages, and then turn that in to a clerk in the construction trailer. That clerk will then hand type all of that information into some type of system, material management system. That will then get checked against eventually a three-way match against an invoice and the packing list and the purchase order. And then that material will sit there. And once the construction is ready, they'll go to their drawings. They'll fill out a material requisition form, usually on paper, turn that into the clerk. The clerk will hand type a requisition into the system, print another paper copy, pick list. They'll go out into that yard, they'll search looking for that paint sticker marker for the spool number or the label, find that material, deliver it to construction, sign for it, then turn that piece of paper back into the construction office for the clerk to hand code that back into the material system to maintain the inventory. So this is very, very paper-based, manual. Takes a lot of time, a lot of room for error in that process. So when we talk about material readiness, the basis of that is leveraging the technology to support a track and trace as the foundation for material readiness. So first, to be able to provide a material readiness solution, you have to be able to know where's my materials. That is a track and trace system, whether that's done with RFID or that's done with a barcode. It can be done with a paint marker as well. But the point is, it's automated in a system that has some geocoded reference of where that material is. So now you can start to automate some of those transactions for material receiving, being able to locate your material, find it faster, and in the case of RFID, you can get updates when that material moves and not have to worry about confidence in your data and confidence in your inventory. You're essentially getting 100% cycle count every time you sweep your yard and get updated reads from the RFID tags. So once you have a track and trace, an RFID-based system in place, that's the foundation. That's going to tell you where my materials are. Next, we've got to incorporate the upstream process of supplier-initiated digitization. So this is getting your suppliers on board. Whenever you're going to receive that material, traditionally that's done just marking up a packing list on a clipboard. To be able to get that data into a handheld device like an iPhone or an Android, you've got to have good data, and that can be very easily accomplished. And the best practice we've seen is onboarding a supplier to do that work process. So we're talking about creating a program here for supplier-initiated digitization where the suppliers will create a digital packing list into your system so that the warehouse crews are able to receive against that shipment on a mobile device. So what that looks like is you would get that data from the purchase order, do an export of your from your procurement system, load that into material readiness software, and then onboard your supplier, let them provide the tagging, whatever makes sense. It could be an active tag, a passive RFID tag, it could be a barcode, and systems allow for the supplier to use their own barcodes as well. It's a very easy thing to do, but you get them onboarded with the tagging and then create a shipment, an electronic packing list that then can interface with the project's material management system so that you can digitize the receiving process. So it sounds like a lot of work. We've seen that on average, because you could have hundreds of suppliers on your project, right? We've seen on average it takes about 3 hours to onboard a supplier. So there's not a lot of effort. If you use a standard practice, give them a little guidebook, a bit of instructions. The technology is available. It's very easy. It's I mean, imagine a FedEx type operation where they're preparing their shipments. That they have a system available. It's a few scans, associate the label, tag, boom, create your shipping list and your packing list, and it's digital. So not a ton of effort here. We've seen a lot of success with onboarding that. If it's done early enough, we don't see really any pushback from suppliers on supporting that process, because there's a lot of benefit from them as well. They get real-time visibility of the receiving, the OS&Ds, the management of those OS&Ds, the validation if there's any issues. They're able to reconcile that, get paid faster. So it really is a win-win for everyone involved there. So on the tagging side, choosing the right types of tags, there's a lot that are out there. It can depend on the risk profile and the storage location and how you're doing that. So I won't get into all the details on best practices there, but the project team should go through sort of a tagging strategy on optimizing that for both cost and for the functionality, and then provide that device. It should be an app that the supplier can just download, create their shipping, their digital packing list. Okay, so now that we have a track and trace foundation put in, we have the upstream onboarding of suppliers and creation of a digital packing list. Now we can support field material management, mobile transactions. So this is using an iPhone, Android device to create the receipt, do OS&Ds, take pictures of the materials, save GPS locations upon receipt, view all of the information on work package information, purchase order information, transfer your materials, do your cycle counts, pick an issue, return it, all those field transactions that are done on a clipboard today and take a lot of time. That all starts with a digital packing list and then be able to support mobile transactions downstream. If we can get that data early and get it into the system, we've seen a lot of success in reducing the indirect labor to support that from the warehouse. So up to 50% reduction in the receiving process, 70–90% reduction in locating time. So a lot of these transactions, there's savings in that, and that's easy to measure. That's just a time study. We go out and you can time your crews receiving 20 items and locating 20 items with a piece of paper, and then give them a phone and let them do it that way. So that's real easy. The real benefit is, again, going back to that cruise time, right? Where 15% is waiting, right? We're doing all these things so that we have real-time visibility of the material, so that crews are not waiting. So that material readiness also involves the management of that material while it's on site or in the laydown yard. That could involve field inspections or preservation and maintenance. So again, the status of the materials matters on whether construction is gonna wait on that. You could physically have that material on hand, but if it's damaged, if the inspection preventive maintenance is not properly conducted, or if you don't have the information, a lot of times you have the physical material, but you're waiting on documentation. that's just as important. So having a system that has that all automated, where you can walk out in the laydown yard, scan a material, be able to see all the associated attachments from OEM manuals, from the material specs, from MTRs, pictures of the material, be able to see the history of every time that got read. A lot of that impacts whether construction is going to be waiting on materials or not, even though that material is sitting right there in front of you. Okay, so when we have this in place now, we've got our foundation for a track and trace system. We've integrated our suppliers. We have digital packing lists, and we're leveraging the technology for mobile transactions throughout the field. That's great. Now we've got our single source of truth of materials. We're getting status updates by barcode reads or gate reader reads, and we're being able to see in real time where that material is. The next piece is we've got to be able to tie that to the construction side of when they need it. And that's when we get into some of the business analytics. So let me show this in a diagram here first. Let's say I've got 5 different locations that a piece of material is going to flow to get from the original supplier all the way to the workface. We're leveraging some technology, barcodes or RFID, to get status updates throughout that process. And then what we need to do is integrate the need date, the RAS dates with that. So you can either do that directly with P6. So you can integrate with P6 to provide the construction start dates on that. A lot of companies are not quite there and doing a level 4 or level 5 schedule in P6 to get it to down to the bill of material level. If not, you can interface with a work packaging tool, or you can enter that manually through off of your work package plans. And what we're trying to capture here is, let's say I've got a carbon steel condensate system that needs to be installed. We're going to start that work in 3 weeks. And let's say I've got 10 spools that are involved in that work package. Well, for that work package, it might be okay if I don't have all of them at site. I may have 80% of the material at site, but the other 20%, if it's coming tomorrow, I don't have a problem. So today, folks are pretty limited in their view with the systems that are available on site, because it shows them what's in inventory. And I can look and say, hey, I don't have 80% of my materials, I'm going to be in trouble. Well, if I'm getting the other 20% tomorrow, that's fine. So the other thing is, the project teams know generally how long it takes to get from each node down the supply chain. So if I know a pipe spool for a specific job is in the fabrication process, and it's being and it's waiting on inspection for fab complete, then based on where the fab shop is, it may have to go to a staging yard, it may have to go to some kind of coating or where it is. So you're able to build in forecasted dates off of where it is in the current stage of the life cycle to be able to provide a forecasted for construction date. So this is big. This is what material readiness reporting does. It provides you a forecasted for construction date. So I know my required for construction date, RFC or ROS or RAS, whatever date construction needs it. With material readiness, it's going to provide you at the individual spool or steel piece mark or equipment tag number, based on where it is in the fabrication or staging area, whatever work step it's in, it's going to forecast when that will be on site. So now you can start getting some exception reporting of will that material be, will construction be waiting on that material? So for example, where is the material in the process? Is it ahead of time, on schedule? What materials have a demand that cannot be fulfilled? What materials are affected by stagnant field mobility transactions? And these are all common questions we get asked all the time. To be able to answer these questions without a system, without that single source of truth, without real-time visibility, it's tough. There's a lot of questions that have to get asked. You know, send a lot of different emails to different stakeholders, pick up the phone. It's hard to get that information, and generally what happens is if you don't have a flag being raised that you are going to have this issue, then that question doesn't get asked at the individual piece mark level. What happens is construction waits on it, and then you're asking these questions from a rearview mirror saying, okay, now I'm in this situation. How do I get it here faster? So here is an example of that dashboard. If you look at the columns, these are work steps in the supply chain, from a fabrication process, fab release to the floor, fabrication started, all the way through blasting, coding, the spool's completed, gets loaded, dispatched, received. So these are all work steps where a barcode would be scanned. And then you have green, yellow, red to indicate, according to where it's at of the process, we've integrated with either P6 or with your work-based planning, so we know the required at site date. And then based on whether it's in step 2.10, blasting complete, it knows, okay, how many days will it take on average to get to the job site, and is that going to be an issue or not? So here, this is showing me for a specific work package, which materials in that work package across these steps are currently planned to be behind schedule at the bill of material level for each individual piece. This is huge. This is a type of dashboard that just is very, very hard to assemble, and if it is, it's very, very hard to maintain unless you're leveraging some kind of auto identification system that you've onboarded your suppliers with, and getting that visibility. We can start to do some really, really good things in ensuring construction's not waiting. So again, shown a little bit differently, this is a variance in your required for construction date versus your forecasted for construction date. So again, you want to be managing by exception. You want to be able to give that dashboard and say, hey, here are the 5 items that 3 weeks from now there's gonna be an issue. You either need to expedite that material or change your work plan, but something's gonna give, and you need to make a proactive decision today to make that change. So I'll talk real quick about the data. So, you know, I talked about the upstream side on the suppliers. We've also got to get good data from construction, and there's lots of systems that data's got to come from to be able to provide that real-time access. That's best done through an API. Most sophisticated systems that your organizations will have, or things that are best in class in the market, will have this API, and it's a protocol that allows those systems to talk. And you know, I'd say 20 years ago, this was something that hasn't been made available. So if you look at a lot of homegrown procurement-based systems, they're very robust. They're great tools for what they do. But one of the biggest challenges is that they've built on top of each other to be able to provide a complete solution, homegrown, that just keeps getting tacked on over time. And it's very hard to allow very focused niche technologies to bolt on to that unless you have an API. So that functionality, that technology, you know, sophisticated companies that are doing this now are building it with the APIs. So if you want to bolt on to an Oracle-based system or an SAP-based system or a sophisticated homegrown system, that makes that very easy. Okay, so I'll wrap up here in summary. Material readiness, it provides that real-time system source of truth across the supply chain that is smart based on geographic location. There's configurable workflows based on that geographical spot in the supply chain, and provides relational visibility that is construction centric from fabrication to installation. So to get there, we start with the foundation on a RFID enabled track and trace program. So we know where our materials are, onboard our suppliers, get that digital packing list to start that process, be able to support automated field transactions on mobile devices, pull in the construction need dates through the API, either on P6 or work package system, and then be able to provide that exception reporting and forecasts for construction visibility dates on will construction be waiting on materials. So that's the slides that I have today that I wanted to go through. I think at this time we do have a few minutes for question and answers.
Absolutely. Thank you so much. That was an excellent presentation. And we do have a few questions that have come through. One question is, does material readiness support the development of IWPs created within a CWP?
That's a good question. So it's asking about the support of material readiness within AWP practices. So yeah, the way that works is at the end of the day, you want to provide visibility at the work package level, right? Because it's all about making sure that the crews for that work package will have the materials that are available. So when we pull in that information, it's going to be grouped by CWP and IWP, and then that visibility is really what folks use to request the material from. So traditionally that's done through, going to pulling the drawing and the bill of material and submitting that to the warehouse. So where we've seen companies who are using this is they'll allow their superintendent or some construction representative, could be a general foreman, could be it could be the piping field engineer, it could be whoever is supporting that crew for requesting that material, to go into the software and be able to isolate their IWP and have that visibility on what material is ready, and be able to submit that request to the warehouse by a click of a button in there. And some cool things with the APIs that are available is you can easily be able to integrate that into your workspace planning tool, so that you can get a status visualization on where that material is. So I can go right into the 3D model, I can isolate the IWP, and where I showed that bar graph that showed all those work steps and how many materials are red, yellow, or green, you can get that same view by isolating an IWP in your 3D model as well.
So that means that there's a lot of flexibility, and if you have other types of software that you are using to manage various aspects, you could incorporate, or like you said, bolt on this type of tracking mechanism.
Yeah, exactly. And bolt on is the key word. I'm glad you mentioned that, because to do what I've described here is not implementing or replacing any systems. Again, you've got very robust systems that these companies are already using. All we're doing is leveraging some technology to capture real-time status and location. And then some of the functionality I described today, companies may already have that as part of their processes, but maybe they're missing the real-time, scans of barcodes and RFID and that thing. So you can just pull in that information through the API. If you already have kind of a process that you're going in this direction, trying to answer these questions, but you need that mobile component, you can just pull that in and bolt on the part that you're missing.
So a perfect segue to that is, what are some of the common technical challenges that are often presented, whether it's a bolt-on or a start from the ground up?
Yeah, so the data is going to be the big one. You know, there's not a standard in the industry for, say, like a commodity code library or things like that. So when you're working across many suppliers, the owner, the EPC, they have different nomenclature. And, you know, if you have a digital packing list versus a paper packing list, that becomes a challenge if you don't have consistency in the data. So I'll just give one quick example. If I've got a 3/4 inch valve, my supplier could write it as 3/4 inches. They could write it as 0.75 inches. They could write it as 0.75 inches. And if that's on a packing list, that doesn't matter. But if I'm on a digital, if I've digitized that, then you got to be able to cross-reference that. So you do want to have some quality control in managing a master list and a validation across that. And there's technology that supports it, but it is something that you have to be aware of during the implementation.
Which is perfect. The next question is there a prescribed integrated tag methodology that has been implemented or a best practice during an implementation process?
Can you repeat it? Sorry, I didn't catch all of it.
That's okay. Is there a best practice for integrated tag methodology, similar to what you were describing, that Atlas might have created or that the industry has created?
Yeah, I'm not sure if that direction is going towards a tagging strategy for applying RFID tags or an industry standard tagging for nomenclature on an engineered item. So I can best talk to the first one. I hope the right one. That, you know, what types of tags do we apply and provide for your supplier and that kind of thing. So that's dependent on the risk profile of that material, the environment, that is it going to be indoors or outdoors? Is it going to be sitting on metal or is it going to be hanging? So there is a best practice. We publish a document as part of our onboarding process that provides a guideline or a best practice for that. In general, active RFID tags are going to be the most expensive. So you want to use those on the critical items, like pipe spools, cable reels, maybe bundles of steel that are going to be outdoors. And then even on the spool side, maybe you only want to use that on small bore, things that maybe tend to move a little bit more often, manual operated valves, that kind of thing. And then passive tags, that's a standard. They're inexpensive. They're best for indoors. They're best for things where you can either hang that tag so it doesn't get some interference. And there's a trade-off with those functionality. But yeah, there is. We've done a ton of work to provide some guidelines for that. Yeah.
So I got a little clarity in relation to the question, and it was looking for a little bit of an understanding on the engineered tag standard that an engineer can use to identify the item. So more identification, like you were discussing previously.
Yeah, like an industry standard, not a commodity code, but a tagging standard. Yeah, that's interesting. That comes up often. It came up in a lot of CII research, nominated topics for that. I don't have a great answer for it. It's a huge issue that still exists. You know, I think one of the things that complicates that are suppliers want to differentiate themselves, probably rightfully, in their tagged equipment. So that they don't want to be compared against others, And so to me, I think that's got to be something that gets solved through collaboration with an industry like CII, and a lot of effort from the owners who are pushing that as well. But I'm sorry, I don't have a great answer for that. It's a problem I don't know how to solve.
I understand it's still a work in progress, like many aspects in construction, and that is why FIATech and CII put together annual events. And so save the date for the 2018 Technology Showcase that'll be in San Antonio. This is March 19th through the 21st. Atlas RFID will have a presentation during that time. It's going to be a bit more about data-centric and how to manage and transform the data that you have into usable and manageable materials. So we really appreciate Robert participating in this session and giving us very interesting insight and useful information for future modification and management of material readiness. I'd like to thank everybody for taking some time out of your day, and stay tuned for future webinars. Everybody have a wonderful day.
Okay, thanks, Eva.